Swayam Prabha. Digital India. Educated India.
I suppose if I write like this, it denotes the dimensions, mass to the power of L to the power of etc. This has dimensions of. Okay. So anything to do with any quantity which has length, mass and time is measurable. You agree? M, L, T. It may have a square root that you put it by hand. It may have L squared, etc. So, this is the dimension of the wave function. So, how these things are measured, it goes beyond, right now I can't explain beyond that. Okay, yeah. Now we will come to, somebody asked a question, then immediately I remembered this particular situation. And it is true that in exit polls, it's very interesting. Those of your interest can look into it. There are people who are experts in statistics and statistical mechanics. They are involved in this. They are not politicians. They don't care whether it is this party or that party, or the data is given, they analyze and they tell what is what. There is no question of common sense based prediction there and that kind of thing. So the Chennai Mathematics Institute, there is, its director was one Karandikar. He was the director. I don't know. He was my teacher also. It so happened I have taken a course with him some 40 years back, 45 years ago. He is an expert on that. This kind of statistical predictions based on statistical methods, and he is not a politician. We don't care that. Right. Now we come to wherever you have to make a decision, or wherever you have to extract an information based on large sample. Large sample means what? How large is large? Something, very often people say, sin theta can be approximated by theta when theta is small. Small means what? You write theta small. No. It has to be within the 15 degrees and etc. like that. You have to decide. So how large is, it depends on the context and the large samples. Right. See now, in IIT, how we give grades? You have any idea? How we give? Yeah? No. That is a percent. That is finally announcing it. But how we give a grade? A grade depends on A grade, B grade, C grade, like that, and right. This is based on, anybody? Similarly, you may be having in your among your relatives who are working for MNCs. At the end of every year, they are judged, and they are given best performers, very good performers are giving reward. And how do they do it? You have any idea? No, not heard. Okay. Anyway, I will not go into it, but I will answer this. How to handle this large data? Now, in IIT, we give a grade to all the students. Now, in the first semester, at the end, every year intake is around 1,200. In IIT Madras, every year intake is around 1,200. 40-50 years back, it was around 300. This has become 4 times every year, first year. Now, We have various common courses for them. Mathematics 1, physics 1, chemistry 1, like that. Applied mechanics. These are all common courses. Now, there is something called, the grades are S, A, B, C, D, E, and then U is fail. He has to repeat. Now, they are given points in the range of 1 to 10. Okay? Credits, etc. There is a multiplication factor 10. Suppose somebody gets 9 out of 10. That will be the highest grade. Somebody gets 9 out of 10, 10 out of 10, highest grade. So, highest grade, S is the highest. Next is A, next is B, C, D, like that it goes. This is fail. This is called cup grade. Because this looks like a cup. It's called cup grade in IIT language. Right. Now, there is something called, I don't know whether you people heard about it. It is called this is also known as Gaussian. Have you heard about normal distribution function? I'll be surprised if Balakrishna has not said anything about it, and it's still possible. You said no something. Now, what this normal distribution is? Now we have we have several people. He is one random variable, he is one random variable, he is another random variable. So, collection of all these random variables, because the exam is given to the entire class. Each person is going to answer in his or her own way. Right? Now, this curve is like this. This is this Gaussian curve or normal curve. Now, there are, this is the average. Let us say average is around 50. This is redefined as 0. Somebody gets 60, let us say. That person would be in this scale 10, 20 like this. Somebody gets 40, then that person would be minus 10. You please understand how a normal curve is drawn like this. That means if you have a large sample, then roughly 50% population is going to be above the average, 50% population is below the average. This is what is known as normal probability distribution, or this is also known by a different name, law of large numbers. So this is the average value, mean value. There is something called standard deviation. I will not explain what it is. There is another number. Now I will erase this. This is one standard deviation above 2 sigma, etc. 3 sigma, etc. Then this is minus sigma, minus 2 sigma, etc. Obviously, someone who scores 90, where will be that particular point? It will be somewhere here. Alright, now for a Gaussian distribution, this area is about, I keep forgetting, one can calculate, about 68%. The area between minus sigma and plus sigma. I will write it. The area between minus sigma and plus sigma is about 68%. Then the area between minus 2 sigma and plus 2 sigma is around 84% or so. Then area between minus 3 sigma and plus 3 sigma is already around 97% or so. I'm not remembering the exact numbers. I can sit down and calculate, which I would not like to waste my time. Right. So somebody who gets 100, right, highest grade is yes, 10 out of 10, then 9 out of 10, let us say, then 8 out of 10, like that it will go. So in IIT language here, somebody gets a B or C, it's not bad. C is average. C is average, good, very good, excellent. C is average, good, very good, excellent. Like that it goes. Okay. Someone who gets 90 marks, what grade we should give? 90 marks is somewhere going to be here. Because 90 marks means here. Because it is plus 3, minus 3 sigma and plus 3 sigma, that has the area of 97%. Therefore, this remaining area is what going to account for that missing 3%. So, someone who gets 90 will be here. I would give S grade. There is some freedom to teacher also. I judge, because I have taught the class, I have given the exams, I have evaluated. If I think that certain students have worked very hard based on their marks, I will give them a suitable grade. After all, at the end of the semester, those students who have worked very hard should not lose heart. मैं इतना मेहनत किया but फिर भी मुझे अच्छे ग्रेड नहीं मिला, like that should not be there. That's okay. Now, somebody gets 15 marks. Where that person is going to be? It will be here. Minus 15 here. 35. Is it right? No. So, that person is in this, the total area of this is 1. Total probability is 1. If this person is going to fall here, it will be something like within 10% or so. That person doesn't deserve to be passed. Now, in companies, in MNCs, if you have somebody working for MNCs, you find out from them. How do they assess them? Various parameters are there, and then a graph is drawn, and on the graph where they are going to live. This is called bell curve also. Right? Now, on the other hand, I will give you another situation. This is how the grades are going to be decided. So, several years back, one interesting thing happened. Again, many people, without understanding the rules of probability and the dynamics of statistics, they used them. The situation was like this. I'm talking about 25, 30 years back, or even earlier. And see, in those days, these days, we have entrance examinations for professional courses, engineering, similarly NEET examination, etc. Once upon a time, such things were not there. You have to write an exam, but still many people who were not doing very well in courses, they somehow managed seats in professional courses. In those days, if you had known some politician or a powerful fellow, you can still get a seat this kind of thing was there. This is more or less has come down. I can't say that it is not there. In IIT, that kind of thing won't work. Very strict rules are there. And for example, we have a place called examinations office. That's where the corrections, etc. are done. Even our director cannot enter there. If he comes there, the in charge of that place will tell him, you get out, don't come here. Rules are very strict, and I myself have seen. So in IIT, such thing is not possible. And several years back, what happened? There was one guy, it is in Maharashtra this happened. Okay? His reputation was like this. The parents used to go to him, and parents means what? Their sons or daughters had just completed +2. They were seeking admissions into professional courses. Such parents used to go to this particular gentleman and say that, look, my son wants to get into engineering course, my daughter wants to get a medical course, etc. He will say, no problem, what are the marks? He will listen, and then he will charge a money. 10,000 rupees. In those days, 10,000 rupees was quite a money. 20,000 rupees. So you give the money and then go home. You write your exams. The child would write the exams, etc. His reputation was like this. If the concerned boy or girl did not get the admission, he will return the money to the parents. Acha. If it didn't work out for the boy, he used to return the money. After 2-3 days, he will say, he has not got it, he will return the money. I tried my best, I could not work out, I am returning the money. And those who got the admission, anyway they are happy. The agreement was, if they get the money, if they get the admission, you will not return the money. If it doesn't get the admission only, that gentleman used to return the money. So those who got admission, they were happy. मैंने उसको पैसा दिया, admission मिल गया, like that. And those who did not get admission, they were also happy because he has returned my money. So where is the catch? So nobody complained to the police about this person. Right? So those who got admission were happy. Those who didn't get admission, their parents were also happy. Where is the question of anybody complaining? But anyway, this fellow understood the law of large numbers. What the law of large numbers says is, if your sample is large, you will have people above the average. You will also have the people below the average. Those who are in 2 sigma and 3 sigma, those students who will fall in the range of 2 sigma and 3 sigma, they will anyway get admission without this gentleman doing anything. Whereas those who fall minus sigma, minus 2 sigma, even below the average, they will not get admission, but their money was returned to the parents. So this fellow was making a very intelligent use of law of large numbers or Gaussian distribution without knowing probability theory or without knowing normal distribution, without knowing Gaussian distribution, etc. Okay? See, why I say this is, it is very difficult to have an unbiased sample. I do agree. As I told you, no, I have faced it. Any competition we conduct in IIT, there will be a backlash on us. The way it was conducted, or the selection team, or etc., etc. These things problem will be there. And, so it is very difficult to be unbiased. On the other hand, we can only minimize our bias. We will definitely do it. Wherever we find there are loopholes, etc., we will minimize it. Okay? Is it not interesting this? Any question, please? So you have to ask questions. Generally, I have seen in such sessions, people come out with many doubts, not only about the subject and also about careers, prospectus, scope for various topics. And yeah, the theoretical curve would be perfectly symmetric. This curve goes like e to the power of minus x square by 2 sigma square. This is symmetric about x-axis, right? X replaced by minus x, again still it would be e to the power of minus x square. Sigma is the standard deviation, it's a positive quantity. So, an ideal Gaussian, I would say, an ideal Gaussian would be like this. However, in reality, when we give grades to 1200 students, we will plot their marks and draw the distribution curve. 40 years back, we used to do by hand for 300 people. But now anyway, programs have come even 20 years back and etc. It won't be a perfectly symmetric sample. It's a reflection of the fact that in that 1200 students, various groups have formed. There are various groups. Some groups who are in between plus sigma and 2 sigma. Some people who are even above 2 sigma. Some people who are here like this. So that we can't help it. An ideal Gaussian is a mathematical idealization. So you won't get a perfect Gaussian. Yeah. But these days, even the Gaussian distribution is being questioned. This bell-shaped curve is also being questioned, its validity and etc. But still it is very much there. There are people who are questioning its use. Yeah. So it's for you to ask questions, sir. Sure. It's surprising. Generally, I have conducted such sessions in Vanavani, KV. Many students know they ask questions about careers, what to choose, etc. Probably you are already tired.
Is the wave function only dependent on x or is it also dependent on the time period?
Not time period, at the instant of time. So usually you write like this. Time dependent Schrodinger equation. True. Time is a parameter, it's not a variable.
If a person wanted to pursue a career in physics, what field should he specialize in the future, coming future?
So he is asking a question, if somebody wants to specialize in physics, what field, right?
Would that person specialize?
Yeah, what field to specialize in? It's a very difficult question. I mean, I can't say you do string theory. I can't say that, look, now the current developments is quantum gravity or some experimentally this particular thing is going on. So I was interested, from my case I can tell you, I was interested to study physics. So my father was a school teacher. So he said that, okay, whatever you want to study, you study. My support is there. Now, in those days, there were many computer centers were there. They were teaching D-Base, Algol, COBOL, like that. Every second street or third street in Mylapore, Triplicane, Mambalam, this computer coaching, they were there. And so when I was doing my PhD, most of my books were on quantum mechanics. And one day my father came and said, what is all this quantum, so many books you are having? And then he asked me a hypothetical question. Suppose You put a board. We will teach quantum mechanics here. Quantum mechanics is taught here, so and so. How many students will come? Then I said, nobody will come. If I say I will teach quantum mechanics, nobody will come. Then he said, look at the next street, that Janakram street. There is the big board. So many students in the evening, they are coming there to learn COBOL, ALGOL. Then there was a disk operating system. So all those programs have disappeared. All those programs have disappeared, out of date, all the books are junk. Okay? But in those days, that was the current value. So it is very difficult. So you choose your, you follow what you want to do. Same thing I did to my children. My eldest son, he wanted to study chemistry and then moved on to biology. So madam knows, he was also very much in RSI in those days. And, perhaps he was in very first batch, I think, or second batch, I forgot. And, yeah. And then now he did his PhD in biology, molecular biology, and then he had done his one postdoc, and now he is with the Indian Institute of Science, and it will take some more time to get a suitable placement. That will happen in science. It is not something. So many people, this is very common. After +2, they don't go to college and then go for CA. In 4 years, they complete. By the time, the brightest people, by the time they are 22, 23, they complete their CA and then they earn very well. Such a thing in science is difficult because science education takes a long time. And so you have to ask yourself. For me, every branch in physics is interesting. Similarly, my second son wanted to study economics. I said, very good. It's a very beautiful subject. There is no subject is dull. It depends on you. But having said all that, I would say that physics is a very enchanting subject. One more life, whether I am willing to do physics, I will do. Okay. So I did, as I told you, laser physics, interaction of light with atoms, molecules, how to make better lasers, that kind of work is what I done. I have collaborated with experimentalists to compare theoretical models, etc. And there are others in our department who are working on superconductivity, superfluidity, then nano this, nano that. I don't know what is that nano. And then there are people working on soft condensed matter. String theory, some 3-4 people are there, right? Plasma physics. So it's up to you, which is interesting. But definitely, if you pursue science, it will take care of you. That's you may not be driving a what is that, Rolls Royce? I don't know what it is.
Sir, how does the quantum computers work?
How do they work means?
Like,
You are asking a very generic question.
what the difference between normal computers and quantum computers?
Yeah. See, these normal computers, no, these are usual circuit boards and that kind of thing. There are processors, etc. Whereas quantum computers, they work on what is known as quantum states. So in digital electronics, no, you have either 1 or 0, right? Either switch on or switch off. Now in quantum mechanics, you have a state, a spin state up or spin state down. A general state is like this, some superposition of spin up and then some spin down. So there are two possibilities, just like we saw earlier, several possibilities. Now the probability for spin up is mod A squared. Similarly, the probability for spin down, mod B squared. Total probability is 1. This is what is known as a qubit. This is known as a qubit. Now, in a classical computer, even your calculator, what we have is digital logic, either switch on or switch off. But here, it can't be like that. It should be a linear combination of both the spin states. Now, because of this, what is known as quantum superposition. Because of this quantum superposition, the speed is enormous. It will be difficult for me to go beyond that. In a classical computer, there is a classical superposition. In a quantum system, there is a quantum superposition like this both. This is also known as, this particular qubit is also known as, by a very famous name, Schrodinger's cat. Have you heard about Schrodinger's cat? This superposition is also known as Schrodinger's cat. What it means is that, but Schrodinger had put it in a slightly different way. What he said was, you put it in a chamber, a cat, and then there is a device which emits radioactive particle. This radioactive particle can hit the cat, right? So either if that radioactive particle hits the cats, then the cat is dead. If it doesn't hit, the cat is alive. Therefore, the normal state of the cat is A times alive plus B times dead. Now the question is, when the cat is dead, over, the game is over. Where is the question of existence of this particular state?
So it's exists in both the situations. Until we open up, we don't know it is alive, right? So
That is true. Once you open it, the game is all over, experiment is over. But even inside, what is the state? Is it alive or dead? Is it, it's something like in digital electronics, either switch is on, then the current flows, the bulb emits radiation. If the switch is off, current doesn't flow, you will have darkness. These are the only two states possible. But when you say it's a linear combination of both on and off, that is very crazy. This is quantum mechanics. So forget about the Schrodinger's cat. This is the superposition. There is a difference between quantum superposition and classical superposition. Classical superposition, you know, for example, if on a particular object, a force F1 acts, on the same particle some other force F2 acts, and the total force is F1 plus F2. Whenever you make measurement, this will be there, this will be there. But here, whenever you make measurement, you will have only one of the states, not both. But the state of the system has to be this. Whenever you make a measurement, you are not going to get contribution from both the components. Only one of them will give. There are some interpretational issues with respect to quantum mechanics, but algorithm-wise, perfect. There is a method of calculating, compare with experiments.
So in quantum mechanics, they say that when we do measurement, it will be in such a particular state, behave in such a particular way. But without measuring it, we say that it will be all over the place. It will occupy everything.
See,
we say that another behavior. But how?
I will put it in a more technical language.
Okay.
A quantum system, see, he is there. Whether you observe him or not, he minds his work. Suppose when you observe him, that is going to interfere his activity, let us say. That's a different situation. So a quantum system exists on its own. There is a hydrogen wahan pada hua hai, it does whatever it wants. I don't care at all. But when I look at it with a hydrogen atom, it behaves in a strange way. It behaves in a different way. And so the very process of measurement, it disturbs the system. Okay, that is very much the nature of quantum mechanics.
But how do so if we observe, it will change the nature of the system. But how would we say that this will be the nature of the system before we?
Yeah, I will give you an example. I'll give you an example. So I think I don't know whether you have Young's double slit experiment. Have you seen Young's? Young's double slit experiment. What Young's double slit experiment says is the following. You have a source. It emits light. And then there is one slit here. There is another slit here. So there is a screen. You have your +1 or +2 optics. This is very much described and interesting. Then you get, there is a wavefront which will pass through this. Then you get any point here. You calculate the path difference. Up to this, the path is the same. This distance, this you give some name. Yes, AS1 minus AS2, the path difference. Depending on the path difference, whether it is an odd or even multiple of wavelength, you will get brightness or darkness. This is the classical Young's double slit experiment. Now, when the quantum mechanics subject was coming up, I am talking about between 1925 and 30, they asked a very important question. What is that question? They said, light is anyway quantum mechanical in nature, so I need not worry about its wave nature. Light is anyway quantum mechanical in nature. It exists in particle state. I need not care about what happens in the wave nature. All those things you read in your +1, +2 textbooks, Eisen's principle, etc. Now the question is, very careful. I am going to have a device which will take care of, there is only one photon between the source and the screen. At any given point of time, there is only one photon between the source and the screen. How do you do that? That is experimentalist headache. Why do you bother? Experimentalists will take care of that. There exists only one photon between the source and the screen. Now the question is, will we get the interference fringes or not? Now, if there is going to be only one photon between the source and the screen, will there be interference fringes or not? First scenario, this photon has to go like this or like this. So therefore it will go straight. Interference fringes will not be formed because it's a rectilinear propagation photon. On the other hand, what quantum theory says is, quantum mechanics says is, a photon is a particle, agreed. I am not saying no. I had erased it, no, here, somewhere here. This particular particle, earlier we had here, is replaced by a wave, a hazy wave. Correct? Earlier I had that. I should not have. So, this photon, when it passes through this or this, it doesn't matter. Let it pass through this or this. These waves associated with that photon must pass through both. Because there is a wave nature for the photon. let the photon pass through as a particle through this or this. I don't care. But the waves associated with the photon must pass through both the slits. If I have one more slit, through that slit also it should pass. Once there is this wave here, matter wave here, they will interfere and you would get interference fringes according to quantum mechanics. That was the conclusion. This is a Gedanken experiment. You know what is a Gedanken experiment? Gedanken. Gedanken means thought experiment. Before this actual experiment is done, let us logically analyze क्या होगा, कैसा करना है experiment, like that. Now, it took many years for the people to actually perform the experiment, and they have performed the experiment to several orders of accuracy, and then interference fringes are formed. Right. Now I am coming to your question. I am not observing this. Now I want to observe, fringes will be formed. Now what I want to do is, I want to observe the system. Kya observation? The waves will anyway pass through both, but photon as a particle must pass through this or that, right? So I put a device. I put a detector. What it will do? If the photon passes through this, it will click. It will give a click sound. He has passed through me. If it had passed through it, I can put a detector here. It will. If it has not passed through it, it must pass through this. Photon as a particle. Correct? Now, when this experiment is done, what is the outcome, likely outcome? Is the question clear? Let me again repeat. I will put a detector here. If the photon passes through this slit, the detector gives a click. It has passed through me. If it doesn't give a click, it must have passed through this. Now the question is, Gedanken experiment, thought. What will be the nature of will we get the fringes or not? The fringes will get disturbed. You will get disturbed, you will get the fringes. Depending on the detector, you will not get the same fringes as the fringes which you would have obtained without the detector. Therefore, if you try to observe the quantum phenomena, there will be some changes, disturbance.
Okay, sir.
This is the situation. Okay? I think I have done with this. If you people have any questions, you can ask me.